Anyway, I know Coco was here with you last time, and I know she spoke to you about tangents to circles, a very important part of analytical geometry in grade 12. I just wanted to do a brief recap of that at the beginning of the lesson and then jump into a more sort of difficult application type question. Okay, so just to go through the basics again, when they ask us to determine the equation of a tangent to a particular circle, they're asking us to determine the equation of the tangent in the form y equals mx plus c. It's our job to work out the gradient of the tangent, and it's also our job to calculate the value of the y-intercept. Okay, so there's this particular order in which we do this. We always work out the gradient first, and then we use the coordinates at the point of tangency to sub in our x and our y, and then that allows us to eventually work out our c. Okay, so it's got to be done like that every single time. Okay. The important things that we need to know, first of all, if we look at B as an example, then you guys can either try C or D. The coordinates at the center in the circle given to us at B, the coordinates at the center would be 2 and -3. This point over here is the coordinates at the point of tangency. So let's call that T, 1 and 1. Okay, now this is a bit difficult for us to imagine, okay? We've got the coordinates at the center. We've got the coordinates at the point of tangency. So what does that make line TC? TC is a what? C is the coordinates at the center. T is the point of tangency. So what does that make TC? TC has to be a what matrix? So C is the center. That's it, Chloe. Okay, it has to be a radius. Very good. Okay, so TC is the radius. Now, another piece of important information that good, well done, everybody. All right, another piece of important information that we know from grade 11. Okay, the gradient of the radius multiplied by the gradient of the tangent always gives us -1. Okay, so if we...
Sorry.
Yes.
Sorry, teacher, is it possible for you to quickly switch on your camera and you will switch it off? I just want to spotlight you. Sorry.
Sure, no problem. There we go. It's off.
Thank you so much. We can turn it off now. Thank you.
That's fine, no problem. Okie dokie. All right. So how are we going to use the information that we've got? So TC is a radius, right? The gradient of the radius multiplied by the gradient of the tangent is equal to -1. How are we going to put all of this together to calculate the gradient of the tangent? Can anybody tell me? How are we going to use this information to calculate? Innocent, go for it. Unmute and speak.
Afternoon, ma'am.
Hello, how are you?
I'm good, and yourself?
I'm fine, thank you. What do you think?
Okay, ma'am. We first have to find the gradient of the radius by using the point at the center and point T, should I say?
Good, good. And what formula are you going to use?
It's y2 minus y1 over x2 minus x1.
Lovely. Okay, so if we sub into that, for example, we could end up with something like this.
That's going to give us a -4.
-4, I agree with you. Good. Then what are you going to do after you've got the gradient of the radius?
We're going to substitute the gradient of the radius on that formula of m rad times the gradient of the tangent is equals to -1.
Good, good. So I'm going to say -4 times the gradient of the tangent Lovely. So what is the gradient of the tangent going to be, Innocent?
Is it 1/4? I think. Not sure.
Beautiful. Yes, it is. It's 1/4. Good. Well done. Good. Lovely. Well done. So now you've got the gradient of the tangent. Now what are you going to do, Innocent?
We're going to take, we're going to use the formula y equals to mx plus c.
Good. What are you going to do next?
Then we're going to substitute the point 1:1 and the gradient of the tangent.
Lovely. Okay. So we're going to say 1 equals 1/4 times 1 plus c, and then we're going to be able to work out c. What are you getting as your value of c, Innocent?
It's 1/4, ma'am.
You should be getting 3/4.
3/4, yes, ma'am. Sorry,
Yes,
3/4.
there. No, it's okay. You've done an excellent job here. So it would be y equals 1/4.
4x plus 3/4.
Beautiful. Well done, Innocent. That was perfect. Okay, excellent, excellent, excellent. Okay, are there any questions? Innocent did that so nicely. She could be the teacher rather than me. Okay, so either you're going to do C or you're going to do D. All right, so let's just quickly practice that and then let's move on. Okay, so either C or D, you don't have to do both. Yes, Kamogelo, what's up?
Hi, ma'am.
Hi, Kamogelo.
My question is on the value of C, 3/4. Is it not supposed to be negative 3/4?
No, because remember, you're going to take that quarter over to the other side. So it's going to be 1 minus 1/4.
Oh, all right. Thank you, ma'am.
Okay, no problem. Of course, when you're done, you can pop the word done into the chat. We're going to whiz through the answers and then we're going to get on to something else. Kamogelo, you've got your hand up again. Want to ask something?
Ma'am, I want to ask, you see, we were calculating TC,
Mm-hmm. The gradient of
and
TC, yes.
then my question is, how do you know that the other one is C and the other one is T? So we're
That's just what I
calculating.
called it. So I just used C for center and T for tangent or point
All
of
right.
tangency. Okay, so I just made those letters up.
All right. Thank you, ma'am.
Okay, no problem.
Yay, Carly, you should be able to hear us now.
Yes.
Nice.
Can you hear us? Hey,
you.
yay. Welcome, Carly.
Welcome, welcome, welcome.
Sure. It's a struggle, eh? But I'm
Shame.
learning.
Sorry, Carly.
Sorry about that.
At least now
No
you know what to
problem.
do for next time, okay?
Yes.
Enjoy. Carly, don't worry. I'm sure now you can hear me. The sound is not gone. Teacher Lee is just waiting for everybody to
Yeah, I'm just waiting for everybody to do the work.
work. So that's why you can't hear anyone. But please do give it a try. You either choose C or D. Actually, we're already done.
We've done B. You can either do C or D.
Yes. Yes. Thank you. Isa, it's okay, you can. Lisa, what Teacher Coco made them do the last time is that when they were done, instead of saying they are done, they could choose any emoji and put it on the chat.
Oh, okay. All right. That's fine.
And do a message and emoji if we're done. You can done.
Oh, shame. That's fine.
Yeah. So if you see all these emojis, it means that they are done.
Okay, then I know what it means. Lovely. Oh, okay, lovely. I like that. That's a little bit of fun, isn't it? So nice to put an emoji rather. Cool.
Yeah, it makes
Okay.
it fun. It's like they're choosing.
It is. Okay. All right. So we've got quite a few people that are already finished. Okay. Anybody get the answer to C that they want to share with us? Just the equation of the tangent is fine. What did you get for C if you did question C? Katleho, what did you get?
Hi, ma'am. Hi, everyone.
Hi.
Ma'am, for the equation of the tangent, I got y equals to 3 over 2x.
Is that for C?
Yes, ma'am.
Oh, okay. All right. Did anybody get a different answer for C? Anyone get a different answer for C? Okay, who's got hands up? Kamogelo, what did you get?
I got y is equal to negative 2x plus 7.
Wow, is that for C?
Yes.
Oh, okay. All right, cool. That's fine. I'm just going to see what Innocent got because I think she had her hand up as well. Okay, Mulebo, Innocent's gone. Mulebo, what did you get for C?
Ma'am, I got 1 over 2x minus 2.
Okay, all right. So that is the correct answer. Okay, Mulebo. So you've got the right answer there. That's correct. That's correct, Nkoniza. Okay, that's what you should have had. All right, so let's just quickly go through that for the people that didn't get that correct. I'm not going to do this. I'm going to try and do it as quickly as I possibly can. All right, so what we should have ended up with were the coordinates at the center were -4 and 1. Okay, remember the point of tangency is the point -2, -3. So the gradient of the tangent is going to be 1 minus -3, so that's 1 plus 3 over -4 minus -2, so that would be +2. So here you would have ended up with 4 over -2, which gives us -2. Remember the gradient of the radius times the gradient of the tangent is -1. So if the gradient of the radius is -2, then the gradient of the tangent has to be 1 over 2. You're dividing both sides by -2. Right, so that is correct. Now you're going to sub into y equals mx plus c. So half x plus c. You're going to sub in your point of tangency. So -3 equals 1/2 times -2 plus c. And now you would end up with -1 on the right. So if you've got -1 on the right, you'd have to add 1 to the right, add 1 to the left. And that's why you end up with -2. Why is my pen not working? Okay, so you were correct. It should be half x minus 2. Okay. All right, if you didn't get that, please take a screenshot. And then we'll just quickly go through D. I'm sorry that I'm not asking for your answers this evening. It's just because I want to give you an opportunity to work on a more difficult question. All right, so when it came to question D, matrix. Screenshots, everybody. I'm going to rub it off now. Screenshots, screenshots. Okay, rubbing it off. We would have first had to do something. And that's something that we would have first had to do is to get the coordinates at the center. All right, so, okay, nice, Nkoniza, yes. Good job. Anybody else try D? Nkoniza shared her answer. So completing the square, we would have had that for completing the square on X. When we complete the square on Y, we would have this. We need to take the 5 over to the other side and add 1 and, and add 4 as well. So this gives us X minus 1 squared plus Y plus 2 squared, and that was going to be equal to 10. So at the center, the coordinates are 1 and -2. Again, we need to work out the gradient of TC. So if I start over here with -1, I'm going to subtract -2. So I'm adding 2 minus 2 minus 1 like so. Okay, so that would have left us with -1 over 3. So in Nkoniza, your gradient is certainly correct. because the gradient of TC, the radius, times by the gradient of the tangent has got to give us -1 because our radius is perpendicular to our tangent. So the gradient of TC is -1/3 times the gradient of the tangent is -1. So the gradient of the tangent is indeed 3. Okay, then we're going to go and sub into y equals mx plus c. So y equals 3x plus c. We need to sub in the points, the coordinates at the point of tangency. So that gives us -1 equals 3 times -2 plus c. This is -6. So we're going to add 6 to the right, add 6 to the left, and that's where the 5 comes from. So y equals 3x plus 5 was great. Okay, good. Well done, everybody. Again, take screenshots if you need to. We're going to move on to the next question. Okay. Any questions before I move on? Any questions before I move on, Matrix? Or are we all good? All good.
Just remember, we're going to do an example by ourselves. So you better be.
Okay. All right. Okay. All right. So let's talk about this question over here. All right. So in the example here, we have been told that M is the center of the circle. They've given us the equation of the circle, x minus 2 squared plus y plus 5 squared is 36. They've told us that BC is a tangent to the circle at C. They've told us the coordinates at B, it's 8 and 3. They want us to calculate the length of BC. Now, most of the time when we see the words calculate the length of, we think about distance formula. But I'm going to tell you now at the beginning, distance formula is not going to help us calculate the length of BC. There's something else going on in this picture. So let's just consider the information that we've been given. We know the coordinates at M, right? They are 2 and -5. The other piece of information that we've got is r squared. Remember, this is in center radius form. So if r squared is 36, it means the length of the radius is 6. Aha, Nkoniza, you are a champ. Okay, so Nkoniza, how would you do this? What do you think? You're welcome to unmute and speak. You're quite right. I don't know if everybody else saw that. Nkoniza said, let's use the theorem of Pythagoras. Wonderful. Why? Why can we use the theorem of Pythagoras, Nkoniza? Okay, type it. Shame, is it not going to take not a bit of a mission? Yeah, well done, Nkoniza. The radius and the tangent form a 90-degree angle, making it applicable. Good, because we can only apply the theorem of Pythagoras to right-angled triangles. So Nkoniza is saying that the line CM, just because it's not drawn, we can put it in there. We're allowed to do that. Right angle. Good, Nkoniza. What else can we do? We can connect M to B. Okay, so can you see that you've got a right angled triangle? Okay, and that's why it's all right for us to do the theorem of Pythagoras. We cannot do the theorem of Pythagoras in triangles that are not right angled. Okay, so we know that the length of this line is 6. So what we can do here, Matrix, is we can calculate the length of BM using distance formula because we've got the coordinates at both points. So that would be 8 minus 2 squared plus 3 plus 5 squared. And the length of DM, you should get 10 on your calculator. Okay, and then you can say that BC squared plus CM squared equals BM squared because of Pythagoras. Okay, so BC squared is what we want. CM we know is 6. BM we've calculated. Oh, sorry, beg your pardon, I was supposed to be substituting. We've calculated to be 10. So that means that BC squared would be 64. And that means that BC would be equal to 8. Okay, are we all good? Thumbs up, thumbs down. Everybody happy? Nice. All right. Good. Well done, everybody. Okay, so take a screenshot if you need to. Cool. And now we're going to put pretty much everything that we've done since the start of this course together into one question. Okay, we'll come back to that one if we can, but this is really the question that I want us to focus on. I'm just going to make it a little bit smaller. I can fit it all in. Let's just do that, and then we can see everything on the screen in front of us. Okay, so in this question, they tell us that the circle center is M, BE and EL are tangents to the circle at D and N respectively. They give us the equation of the circle in general form. They give us the equation of the tangent of BE. They tell us that it's y equals half x plus c. 3 questions. Determine the center M, the radius of the circle. Determine the equation of the radius MD and hence show that the coordinates of D are 3 and 4. Last question, if the coordinates of L are 9 and 0, calculate the length of Ln. All right, matrix, it's time to put it all together and try and answer this question. Okay, I want you to do A and B and C. All right, remember Yolanda and I are here to assist you if you need our help. Okay, off you go.
Remember to use your emoji when you're done.
So when they ask you to determine the radius, they want its length. In Kanyiso, they want its length. It's a badly phrased question. They should have said determine the coordinates at the center M and the length of the radius, but that's what they mean.
At least now we know that an exam would do something like this. You're like,
Yeah,
oh, yes, could only
Yeah.
be the distance.
yeah, that's what they mean. That's why it's so important when we're setting exams. We've got to think very carefully about what our questions are asking our students to do, and that they're not ambiguous. It's got to be clear. It can't be difficult because it's easy to misunderstand. It's got to be difficult because it's testing a concept.
That's true.
Yep.
That's true.
Yeah, definitely. Absolutely, Ayanda, not a problem. Okay, not a problem to use that formula at all. Okay, so we should all be finished with A. Continue working. I'm just going to do question A slowly because, as always, time is bearing down on us. And you guys continue with B and C. Okay, so the answer for A is up already. Okay, so CM Tanda, I was completing the square. Okay, so I completed the square for X and I completed the square for Y. Okay, so remember when you complete the square, you've got to take half of the X term. So that would be half of -8, which is -4. And you've got to take that number and you've got to square it. That's where the 16 comes from. What I add to the left, I must add to the right of my equation. And then I did the same thing on Y. I completed the square on Y. So that gave me half of -4, which is -2. Sorry, there shouldn't be no bracket there. That should be -2. And then I've got to take that -2 and I've got to square it. That's why I added 4 to the left and 4 to the right. Okay, and then I wrote my trinomials as perfect square trinomials, and I got my equation into center radius form so that I'm able to determine the coordinates at the center M and the length of the radius. Okay, so the coordinates at the center M are 4 and 2. Makes sense because it's a point in the first quadrant. And the length of the radius is √5. No problem, CM Tanda. Masejo, probably not more than about 3 marks. A mark for completing the square, and then a mark for getting it into center radius form, and then a mark for the coordinates at the center, and then the radius. Okay. Okay. How are we doing with the equation of the radius MD? Is anyone willing to yes, who's that?
Naledi.
Oh,
Naledi.
Naledi. All right. Naledi, did you want to give an answer or ask a question?
Ma'am,
Anyone?
it was not Naledi, it was me.
Oh, was it you, Katleho? Okay, all right. Katleho, did you have an answer for the equation of the radius?
Ma'am, I don't necessarily have an answer. I do have an answer, but yesterday my answer was wrong. And I kind of like did not like my way of finding the answer was wrong. So, ma'am, I did not like grasp, or not yesterday, ma'am, it was Tuesday. I did not grasp what the teacher said per se, ma'am. So I do have the answer, but I might have done it the wrong way.
Okay, well, just tell me what you've got, because you know what, even if you've got it wrong, it doesn't matter. It's not the end of the world. What did you get?
The equation of the radius, ma'am. Oh, okay, ma'am. So the equation of the radius, I got y equals to -2 x plus 10.
Can I tell you something?
Yes, ma'am.
That's right.
Oh, okay then.
Yeah, isn't that good? Doesn't that feel good? Hey, that's lovely. Okay, so you obviously did grasp it. Okay, that's really nice. Well done, Katleho. Okay, very good. Okay, so the rest of us should have got the same answer as well. We should have got the equation of the radius to be y equals -2x plus 10. I'm just going to quickly do the solution to that, just in case there's anybody who didn't get that. This is what we should have done, and then we can talk about how far you are with the rest of B and C, because we're obviously starting to run out of time. Okay, so to get the equation of the radius, we know the coordinates at the center are 4 and 2. The equation of the radius dm, that's this line over here. Okay, so we know that the radius is perpendicular to the tangent, and we know that the gradient of the tangent is a half. So we would have said that the gradient of the tangent multiplied by the gradient of dm is equal to -1, because our radius is perpendicular to our tangent. So if the gradient of the tangent was a half, dividing both sides by a half means that the gradient of the tangent had to be equal to -2. Okay, at the point of tangency, or sorry, no, we can't use the point of tangency at this case because we don't know the coordinates of D yet. We've got to use the coordinates of M because DM goes through M. So we're going to use these coordinates over here. All right, so we're going to say y equals minus 2x plus c. We're going to sub in M because DM goes through M. And put 2 here, 4 there, add 8 to the side, add 8 to the side, and you can see you were perfectly correct. Katleho. Okay, so minus 2x plus 10. Good job. Okay, now that's this bit over here done, and hence show that the coordinates of D are 3 and 4. Has anybody been able to do that? Yes, Kamogelo.
Good evening, ma'am. I just wanted to ask, how did we get y equals to -2x plus 10?
Okay, so that's exactly what I was explaining here in the green. Okay, so what we would have done is use the gradient of the tangent, which you know is a half, times the gradient of the radius, dm is -1. So the gradient of dm is going to be -1 divided by a half, which is where the -2 comes from. Then you're going to sub the -2 into y equals mx plus c. And the line dm goes through point M. You don't have the coordinates at D yet. It says, and hence show that the coordinates of D are 3 and 4. So you can use the coordinates of any point on a line to find the equation of that line. That's why we're subbing in M in this case. So the 2 is the y coordinate, the 4 is the x coordinate, and that makes C equal to 10. Okay.
Okay, thank you.
All right, no problem. Now, when it comes to proving that the coordinates at D are 3 and 4, is there anybody who's done this and wants to tell us how they did it? Is there anybody who did this and wants to share their answer on how they did it?
Ma'am,
Yes, Katleho.
I also did this one, but ma'am,
What
still
did you?
I think I used the wrong method, but I got the
Okay.
right
Okay, so
one.
what did you do? Tell us what you did.
Ma'am, I basically did what I did on Tuesday, but I got it wrong on Tuesday, but today I got it right. I don't know how. So, ma'am, after doing it, ma'am, can you please maybe show me another way to do it so that I can be able to always double check?
Sure. So what method did
So,
you use
ma'am,
this evening?
ma'am, I used the gradient method, ma'am.
Okay, so if you use the gradient method, all right, so what you would have done in that case is you would have said that the gradient of line BE is 1/2, right? You don't know the coordinates at D, it's X and Y. So we would have ended up with Y minus 2 at the top, and at the bottom we would have ended up with X minus 4. Okay, which if we now cross multiply, that would give us x minus 4 is equal to 2y minus 4. If I make x the subject to the formula, x would be equal to add 4, add 4. So x would be equal to 2y. Did you do that?
Not really, ma'am. No, ma'am. And
Okay.
ma'am, I did not substitute not that 1/2, ma'am. I substituted -2. I used the gradient of the radius, ma'am.
Oh, so use the gradient of the radius. Okay, how?
Ma'am, what I did is like I think it's mathematically incorrect somewhere. But ma'am, so ma'am, basically I said y -2 all over x -4. Ma'am, I actually said 4 minus x. I said 2 minus y2 all over 4 minus x equals to -2, ma'am. Well, equals to -2 all over 1, ma'am. And then, ma'am,
Okay.
I equated x by the side, and then I equated y by the side, and then, ma'am, I found the answer.
Okay, so now you are saying over here, okay, of course, that's the gradient of this line. Sorry, DM. Yes, of course, sorry. I beg your pardon. I was wrong in what I did there. Okay, so that would give you -2x plus 8 is equal to y minus 2. Okay. And then if you take that over to that side, then you're going to end up with y is equal to -2x plus 10. Okay. So the reason why this is not going to work, all right, is because you're going to end up with the same equation that you've got over here. What you would need to do is you would need to solve simultaneously. All right, so what they actually want you to do over here is point D. I just want to point this out to you, Matrix. Point D is a point of intersection of 3 things. It's the radius, it's the circle, and it is the tangent. Okay, so we can solve simultaneously between any one of those 3. What they actually want us to do here is to solve simultaneously using the equation of the radius and our circle. Okay, so our circle is x minus 4 squared plus y minus 2 squared is equal to 5. Also, you've got this equation over here. So what we're going to do is we're going to take that y and we're going to sub it in there. So you would end up with x minus 4 squared plus minus 2x plus 10 minus 2 squared equals 5. Now we're going to tidy it up a little bit. So that's going to give us x minus 4 squared plus -2 plus 8 squared is equal to 5. No. So in Konaise, when it says show that, you are not allowed to verify by substitution. They want you to prove it. So they want you to do this simultaneously. Okay, so you wouldn't get any marks for that. Okay, so that's why I've got to do it simultaneously. I'm not, if I take what they give me and I sub it in, then I'm verifying, I'm not showing or proving. Okay, and then you would have multiplied out your brackets. So that would be minus 8x plus 16. Then here that would be plus 4x squared minus 32x plus 64 minus 5 equals 0. So that gives us 5x squared when we start collecting like terms, minus 40x, and then this would be plus 75 equals 0. Okay, now you would divide through by 5 or use the quadratic formula. So x squared minus 8x plus 15. Factorizing. And there we can see one of our answers comes up. So either x is equal to 3 or x is equal to 5. Okay, so we would select this answer. Okay, at D, x is 3. You can sub into your straight line to get the y coordinate. So y would be equal to -2 times 3 plus 10, and that's where you'd end up with the 4. So that's why the coordinates at D are 3 and 4. Okay, matrix. Any questions? Please remember to take screenshots. Any questions?
And also, ma'am, if you use the 5, ma'am, it would have given you 0, and X is not in the origin, so ma'am,
Exactly. Exactly. Quite right. It wouldn't have worked. Okay. Is everybody happy? Is that making sense to you guys?
Well done,
You
Matrix.
sure? Okay, Matrix, that's great. All right, so hopefully you're taking screenshots. You've got all of this down and you're all okay. Of course, if you were here from the beginning of the course and you've practiced all the solving simultaneously and the completing of the square and whatever, it should be all right. It's just everything now coming out in one question, which is exactly what's going to happen in exam questions. Just very, very quickly, guys, before I know you've got to go, you've got to do the quiz. I just wanted to do the last question with you. It's just, again, a continuation of what it is that we've done tonight. There you go, Zetu. Just take screenshots. All right, so just very quickly, how would we calculate the length of Ln? Remember, we are allowed to connect M to L in order to make a right angle triangle. We know the length of the radius Mn. We know that it is √5. We know the coordinates at L, it's 9 and 0. We can use distance formula to calculate the length of Lm. So that's going to give us 9 minus 4 plus 0 minus 2, and we get √29. Theorem of Pythagoras. Okay, mn squared plus nl squared equals ml squared. Okay, mn is √5. nl or ln is what we're trying to calculate, and this is √29. Okay, so ln squared is going to be 29 minus 5, which is 24. So ln is √24. Okay, guys, so that is sort of the closest thing you're going to see to an exam question. Okay, any questions quickly before we say goodbye? Oh, it's a pleasure, Keithlin. I hope you enjoyed the lesson. All right, remember, if you can possibly sign up for boot camp, it's going to be 3 lessons the last 3 weekends in May. We're going to get you prepared for your June exams. Okay, please join Yolanda and I promise you it's going to be very interesting and very helpful.
Yeah.
Okay. Otherwise, the quiz is available this evening. If you're done, you're welcome to log off and say goodbye. Any questions? It's a pleasure, Trish. You have a good night too. Any last questions on what we've done this evening? You're welcome to ask. It's a pleasure, everybody. Pleasure, pleasure, Keithlin. Pleasure, Carla. Bye, Nkuniza. Well done. Bye, Natalie. Bye, Toko. Bye, Siamtanda. Pleasure. Pleasure, iPhone. Pleasure, Masi.
Hi, ma'am.
Masike. Hello.
Can I ask some question?
Yeah, of course you can.
Is it possible to be given, let's say maybe the equation of the circle as negative x squared, maybe? Or,
No.
or it's
No,
not
so
possible?
it's not possible with a negative. No.
Oh,
No,
okay.
the coefficient can change. It doesn't always have to be 1. As long as the coefficient of x squared and y squared is the same, you're always going to be dealing with a circle. If the coefficient of the x squared term and the y squared term are different, then your circle becomes oval in shape. But that's beyond our scope of CAPS, so you don't have to worry about that. But no, it's not going to be negative.
Okay, thank you so much.
Okay, the pleasure, no problem.